Good evening, everyone. So our topic is today just discuss limit little bit and continuity, and main topic is derivatives. So how we come up with derivative differentiability of a function. So you have learned limit and continuity in week 7, right?
Yes, sir. Yes, ma'am.
So there is any doubt in those two concepts because differentiability is just based on limit. It is the limit of some specific function. So you have any doubt on limit?
No, ma'am.
So suppose you have a function f of x. This is your function. And we have a point A which is belongs to domain of f. Or in general, we can say, this may confuse you. If we have a function on the whole real line, and we have a point A belongs to real line, then we say that limit extending to A f of x, this limit will exist if the right hand limit and the left hand limit are the same at a point A, right? So in general, we say that if limit x goes to A positive, f of x is same as limit x goes to A negative, f of x. Then we say that at a point A, the limit will exist. So everyone is familiar with this fact, right? This is a basic definition of existence of limit.
Yes, ma'am.
Now, what do you mean by continuity? So suppose
When this limit is the same as f of a.
Yeah, and whatever the quantity will get over, this is same as limit extend. We say that this is the limit of f of x as x tends to a. Sorry, in continuity, this is the case. That in continuity, so we say that a function f is continuous at a point A if limit extending to a f of x is equals to f of a. This is a basic definition of continuity, right? Okay. Now I go to differentiability. So derivatives are mainly used for calculating the instantaneous speed of any vehicle. You have already uh, heard in the lectures also. But in general, derivatives are defined as a limit of certain quotient. I'll tell you that let us suppose again, if your f is a function and we have a point A is our point, then we say that the derivative of f at a point A is just the limit of this thing, that limit h tending to 0, f of a plus h minus f of a by h. So this is the basic, and this limit is denoted by f dash at a. So what happened here? This function, this thing you can observe as a function of h. I mean, this is something, the function of h, right? We are tending h to be 0. Here our a is fixed and we are tending our h to be 0. So at the bottom of things, we just calculating the limit of some certain function at a point 0, right? So if you observe, this is a function at h, this suppose g of h is my this, that f of a plus h minus f of a by h. Then what are we doing? So we are saying that f dash of a is nothing but limit h tending to 0 g of h, right? So if this limit exists, then we say that our function is differentiable at a point A, and the derivative of that point is nothing but the value of this limit. Okay. So now suppose our function g of h is this, that f of a plus h minus f of a by h. I want to say that my derivative exists, so that means the limit h tending to 0, g of h, this limit exists. So what does that mean? That the left hand limit of g of h, this should same as right hand limit of g of h at h is equals to 0, right? So that means we say that limit h goes to 0 minus f of, yeah, this is same as limit h goes to 0 minus g of h, and this thing is right, can be symbolized as limit h goes to 0 plus g of h. Okay, so we say that if we say that this limit will exist, so that means the left hand limit of g of h and the right hand limit of g of x should be same at h is equals to 0. So that means this limit, that limit h goes to 0 minus g of h. So what does this mean? This means that we are approaching 0 from the left hand side, right? So this limit should same as limit h goes to 0 plus g of h. So if I want to write these things in the term of f, so what we'll write? So limit h goes to 0 minus f of a plus h minus f of a by h. This should same as limit h goes to 0 plus f of a plus h minus f of h by h.
Okay.
Sorry, this is f of a by h. So this limit is sometimes known as left hand derivative. In place of left hand limit, we'll use left hand derivative of f of x, and this limit is known as right hand derivative of f of x. So you got when the function is differentiable at a point a, if this limit will exist, then the function is said to be differentiable at a point a, and the derivative of function is nothing but the value of this limit. Got it? Any doubt?
No.
So there is simple relation. First, we'll discuss limit. What do you mean by limit? Just the right hand limit is same as left hand limit. That means at some certain points we are approaching from right side, left side, and we are approaching from right side. So we should go to the same place. That is the meaning of limit in R2, right? Okay. In R2 means in a plane. And by continuity, we means our limit should equal to some certain specific value, which is equals to f of a. Then we say that the function is continuous. And then we will define the derivative. So derivative is nothing but the just a limit of a special type of function. So this limit of this function. So then we say that if this limit will exist, then we say that our function is differentiable at a, and the derivative is just the value of this limit. Okay. So this is just based on the calculus stuff, that how calculus will define differentiability, limit, and continuity. There are so many applications of derivatives. First of all, derivatives, they are used to calculate the instantaneous speed of any object. This is the one example. They are also used in the finance field to calculate some profit. I'm not sure exactly what they call that, but there are also some used in finance also. It is not just some mathematical term which used here. So derivatives has so many applications in several fields. So that's why you should know what is the derivative of some basic functions. Okay. So now we'll calculate some derivatives of some basic functions, starting with linear functions as usual. You guys know the formulas of derivative for any function? That how do you calculate?
We can attempt, ma'am.
Yeah. So now what happens? So here we will calculate derivative at certain point. For example, here I am calculating derivative at a. Right? So in place of a, I can take any random point x and I can calculate the derivative at that point. So in general, we'll denote it by f dash of x. So this f dash of x is now a function of x, right? And this f dash of x is calculated by this limit, that limit h goes to 0, f of x plus h minus f of x by h. Here f is our given function. So what I was saying, that if you calculate this limit, this limit will come in some terms of h, right? Because here h is going to 0, but x is independent of h. So x will stay, right? So we'll denote it by some function of x, and this is just a symbol, right? So we are using this symbol to denote the derivative of f at a point x. And this function is known as the derivative function of f. So here f dash of x is called a derivative, not the derivative. It's called a derivative. Derivative function of f. Okay. So now we will calculate some of the basic derivatives if possible. Okay, so I'll give an example. So you guys try. Write f dash of x or f of x is equals to x by x minus 1 using the definition. Okay, so you guys can calculate, just use the definition, just write f of x plus h, what is it, and f of x, and put it into limit and try to find out the limit of that quotient. Okay, so use this thing, that f dash of x is nothing but limit h goes to 0, f of x plus h minus f of x by h. Okay, so I'm giving you 5 minutes because we'll take some calculations. So 8:35. So try it out. Okay, so let's solve this question. So here given that f of x is x upon x minus 1. So now we will write f of x plus h. So f of x plus h will be x plus h upon x plus h minus 1. And what is our limit? So f dash of x is nothing but limit h goes to 0, f of x plus h minus f of x by h. This is same as limit h goes to 0. So I'll just put this 1 by h this side, and it will become x plus h upon x plus h minus 1 minus x upon x minus 1. Okay. Now this is same as limit h goes to 0, 1 by h. We'll try to simplify it. Okay, so this is x plus h minus 1 into x minus 1. This will come here. So it is x plus h into x minus 1 and minus x of x plus h minus 1. Basic multiplication rule of quotients. So this is same as limit h goes to 0, 1 by h. In the denominator, we have x plus h minus 1 into x minus 1. And in the numerator, we have x square minus x plus hx minus h. X square minus xh. So this x square and that x square will cancel out. Similarly, minus x plus x. Similarly, h into x. Am I audible clearly?
Yes, ma'am.
Yes, ma'am.
So hx and minus xh will also get cancelled. And this minus of h and this h will also get cancelled out, right? Okay. So that means at the end we will get limit h goes to 0. In the numerator, we just have minus 1. And the denominator, we have x plus h minus 1 into x minus 1. So here we get some function which is of the form p by q, right? Px by qx. And we know that whenever if limit, if I'll put the value of a in the qx and it is not going to 0, it is not equal to 0, then I can directly calculate my limit. So that's why I'm able to put the h is equals to 0 in here. So it will become minus 1 upon x minus 1 into x minus 1. So this will become minus 1 upon x minus 1 the whole square.
Ma'am, could you repeat the last step? The statement you just said.
Yeah. So I was saying that whenever you have px by qx type of limit, and you know that if suppose this limit h goes to 0, so if I'll put my q of 0, and if this is not equals to 0, then we can calculate the limit directly by putting the value of x. That was I'm saying. I think I also repeat this in the last video, but yeah, you should remember that whenever you have some quotient px by qx where both are the polynomials precisely, and if whatever point, if suppose I have to calculate limit x goes to a, and if I am putting that q of a is not equals to 0, you can just calculate the limit by directly putting the value x is equals to a. That will work for you. That was the answer, right? Now you got it?
Irrespective the value of h, like
Yeah, we just substitute the value of h. So it will become x minus x plus 0 minus 1. So it will become x minus 1 into x minus 1. So it is minus 1
okay.
upon. Yeah.
Got it. Thank you.
So we will get f dash of x is equals to minus 1 upon x minus 1 the whole square. So I want to find what is the value of f dash of 2. So it is minus 1 upon 2 minus 1 the whole square. So it is equals to minus 1. So f dash of 2 is equals to minus 1. Okay. Fine. So this is the basic limit, basic definition of derivative, which we'll use to prove certain theorems. For example, you know, I think you know that if f is differentiable at x is equals to 0, then this statement will imply that f is also continuous at x is equals to 0. This is your statement, or I can call it theorem. So this theorem says that if you have a function which is differentiable at x is equals to a, then that function is also continuous at x is equals to a. We can easily prove it. So just see the proof. So what is given to us? So given to us that f is differentiable at x is equals to a. So that means our limit h goes to 0, f of x plus h minus f of x by h. This limit will exist, right? Right. In continuity, what we have to find? In continuity, we have to show that, so this is our claim. For proving the continuity at a point A, we have to show that limit x tending to A, f of x is equals to f of A, right? This is what we have to show. So we can replace this limit by this limit, that limit h goes to 0. In place of x, I'm just replacing x plus h, right? Because if x goes to A, then, sorry. F of A plus h, that is x is equals to A plus h. So if our x will goes to 0, so give me 1 minute. Yeah, we should start from the beginning and then it will follow. Okay, fine. The proof is not that much important. So this is your fact. You should remember that if a function is differentiable at a point A, then it is automatically continued at that point. Okay. So I'll give it proof using some other theorem. It will use some other theorem which is not here. So for the matter of fact, you just remember this one. Okay. Now there is another formula for calculating the derivative, which won't use the x plus h, that term. So that means f dash of x. This limit also can be written as limit some, so I'll take z goes to x. For in the previous limit, what I did, that f dash of x is nothing but limit h goes to 0, f of x plus h minus f of x by h. This is our main limit. This also can be written in this way, that f of z goes to x, f of z minus f of x by z minus x. This limit and this limit is same because you just put z minus x is equals to h. Then if your h goes to 0, then your z, so this is means that z is equals to h plus x, right? So if your h goes to 0, then your z also goes to x, and this f of z will become f of x plus h, and f of x will remain as it is, and this will become h. So this formula, that f dash of z is limit z goes to x, f of z minus f of x by z minus x. Okay. So this formula just involve a function at single point. I mean, in this formula, we have to calculate f at x plus h. So if we have some function which is involving some square, so suppose I have a function f of x is equals to x cube. Then for this term, I have to calculate x plus h the whole cube, which is more complicated. And here I just have to calculate f of z, which is z cube, right? So this is some another form of limit, and this is also the same form of limit. So we have two form of limit for derivative, that f dash of x is equals to limit h goes to 0, f of x plus h minus f of x by h, and f dash of x is equals to limit z goes to x, f of z minus f of x by z minus x. Both limit can be used to calculate the derivative. Any doubt till now?
No, ma'am.
No, no.
No, ma'am.
So now here comes the standard example, that you guys know that f of x is equals to mod of x. The graph of this function look like something like this. This is some point, and yes, this is your y is equals to minus x9. This is your y is equals to x9. You know that this function at a point 0 does not have derivative, right? Because at a point 0, the tangent won't exist, and one fact is that the derivative of f at A. So that means f dash of A. This also calculate the slope of tangent. Slope of tangent at point A of curve f of x. Okay, this is the one. This is also the one significance of derivative. That derivative eventually calculate the slope of a tangent line at a point of a function f of x. So here your function f of x is mod of x. So we know that mod of x at 0, there are there does not exist any unique tangent, right? You know this fact, right? Because
Sorry,
at 0,
Yes.
that at a point 0, there does not exist any unique tangent, because this L1 line is also tangent. This line is also a tangent, right?
yes, ma'am.
Yeah. So we can also say that at this point our derivative also should not exist, because if our derivative exists, then we will get our slope of a line, and we also have a point, so we can easily calculate the unique line, right? Because if what I'm saying, that if the derivative of this function will exist at a point 0, then we get a slope of tangent line, and we know that the tangent line should pass through 0, so we get a unique equation of line. This should not happen, right?
Yes.
So intuitively we get some intention that okay, so derivative of this function should not exist. So we'll prove it using the formal definition. Okay. So we'll try to find out what is the f dash of 0. So f dash of 0 is nothing but limit. Again, we'll use the standard definition. H goes to 0, f of 0 plus h minus f of 0 by h. Okay. So this is same as limit h goes to 0. This will become mod of h minus 0 by h. So this will become limit h goes to 0, mod of h by h. Now this is something limit you should calculate using the left hand limit and right hand limit. Okay. So this is mod. So the limit h goes to 0 minus mod of h by h. What is the value of this? Anyone can tell? Yes. You are not audible correctly. You can message in chat box. So what is the limit? What is the right hand limit of this function mod of h by h?
It's 0 by 0, so
minus 1.
undefined.
Minus 1.
No, that's the catch here, because what happened when we go
Minus
from
1.
yeah, right, minus 1. When we go from left hand side, what is the mod of h? This is the equation of mod of h, right? I mean, this is the graph of mod of h, right? So when we come from the left hand side, this line will become y is equals to minus h, right? So from the left hand side, what is our limit? So left hand side, this will become simply minus of h upon h, which is equals to minus 1. So this
Okay.
limit equals to minus 1. So you got it? Yeah.
Yes.
And similarly, if we come from the right hand side, this mod of h behave like an h, I mean positive function, right? So this limit will become this mod of h upon h. This is nothing but limit h goes to 0, h upon h, which is equals to 1. So that means this limit won't exist now, right? Then because the left hand limit is minus 1 and the right hand limit is plus 1, which are not equal. So that means our f dash at 0 does not exist. Got it? Someone is saying something? Hello? Any doubt till now?
No, ma'am.
No, ma'am.
Fine. So we get that the function f at point 0. Now I'll write some standard derivative formula which will use. Probably you guys know already, but So now, suppose our function is a constant function now, right? Okay. C belongs to real number. So this is our constant function. Then what is the f dash of x? What is the value of f dash of x? Let's calculate using the
Zero.
limit. It's easy. Yeah, correct. 0. Why? Because f dash of x will become limit h goes to 0. F of x plus at what yeah, f of x plus h minus f of x by h. This is also c and this is also c because our function is constant. So c minus c will become 0. So the limit will become 0 for all x. So that's why f dash of x is equals to 0. So if our function is a constant function, then its derivative is 0. Intuitively, we also clear that if our function is a constant function, then this is the graph of that function, right? F of x is equals to c. Correct? So at any point of the graph, the tangent line will also coincide with the graph. So that means it also has the slope 0, right? So if we have some horizontal line, then we know that the slope of horizontal line is 0. So tangent line at some point x will also coincide with the graph of constant function. So it also has slope 0. So that's why the derivative 0 will make sense, right?
Yes, ma'am.
Yeah.
Now we have other function f of x is equals to x to the power n. So what is the derivative of f dash of x?
Nx to the power of
And
n
x
minus 1.
power n minus 1.
Yeah, correct. Nx to the power n minus 1. Now how it will come? You just have now here we have some polynomial function, right? X to the power n. So if I want to compute f of x plus h to the f of x plus h, this will become f of x plus h to the power n. So then I have to split it up into n factors and do the calculation. So something I got intention that okay, this limit may be complicated. Okay, so we'll just use that z limit. That f dash of x is nothing but limit z goes to x, f of z minus f of x upon z minus x. So we'll use this definition to show that if our function f of x is equals to x to the power n, then f dash of f of x is nothing but n into x to the power n minus 1. So this is same as limit z goes to 0, z to the power n minus x to the power n by z minus x. Then you know that what is the formula for z to the power n minus x to the power n? No? Okay. So z to the power n minus x to the power n can be factorized. You know this formula, right? A square minus b square. This is something like a plus b into a minus b, right? So similar thing will happen here, that it will be factored out into some z minus x and z to the power n minus 1 plus z to the power n of x square plus and so on. At the end, we get z to the power n minus n x to the power n. This will become 0. So at the end, we'll get z to the power x to the power n. You can note it down because it will use in several, I mean, so many times you will going to use this factorization. Okay. So if I'll put it here, this will become limit z goes to x. Sorry, this is not 0. This is x. Now here also we get some px by qx, but if I'll put z is equals to x, our qx will become 0. So that's why we cannot directly put our value of z to get the limit. So that's why we have to factor it out and try to cancel the something from the so that's why
Ma'am, you're breaking, ma'am.
in this
Ma'am, you're breaking, ma'am.
is 2 times x plus and so now Am I audible now?
Yes, ma'am.
Now give me 5 minutes for sharing my screen. Hello? Hello?
Yes, ma'am.
Yes,
Am I
ma'am.
audible clearly now?
Yes. Yes. Yes.
Yes, ma'am.
So now what we are doing, so we want to calculate the derivative of this function, that f of x is equals to x to the power. So we will use this definition, the second one, that limit z goes to x of f of z minus f of x upon z minus x. So just put our values of f of z and f of x. It will give us z to the power n minus x to the power n. Now I'll use this extension of z to the power n minus x to the power n. And by the cancelling the factor, we get this polynomial in z. Now this is something polynomial in z, so I can easily put the value of z is equals to x. So now we'll put z is equals to x to get our limit, right? So if we put z is equals to x, what it will give? So it will become x to the power n minus 1 plus x to the power n minus 2 into x, again plus x to the power n minus 3 into x square, plus and so on. At the end, we'll get x to the power n minus 1. Sorry. Okay. So this is nothing but x to the power n minus 1 plus x to the power n minus 1 minus 1 plus and so on plus x to the power n minus 1. This has become n x to the power n minus 1 because they are n terms. Okay. They are n terms because ultimately we are minus at the last term, what we will get? Z to the power n minus n. So that means we are doing this thing n times. So that's why they are n terms. So at the end, we'll get nx to the power n minus 1. Okay. So what we get? We get that sometimes derivative, I mean f dash of x is also written as d by dx of f of x. This is also one of the notation derivatives. So that means that d by dx of x to the power n is nothing but n x to the power n minus 1. Okay. Now it is clear. Any doubt? Am I audible?
Yes,
Yes,
ma'am.
ma'am. No doubt.
This fact is clear.
Yes.
Yes, ma'am.
Now, as we know that the limit of we know that if we want to calculate limit x goes to a, f of x plus g of x, then this is same as limit x goes to a of f of x plus limit x goes to a g of x, right? So similar thing will also happen in the derivative, that if we want to find dy dx of function f of x plus g of x, this is equal to dy dx of f of x plus dy dx of g of x, or we can say that f of x plus g of x dash, so also right, same as f dash of x plus g dash of x. Okay, now I'll give you example. Find f dash of x for f dash of x for f of x is equals to x cube plus 4x square minus 5x plus 6. What is the f dash of x, and then what is the f dash of 1, I guess. Just evaluate using those two formula. So formulas are that f dash of x is equals to n x to the power n minus 1 for fx is equals to x to the power n. And you can also pull out the scalars from the derivative. That means that dy dx of c of f of x, this is same as c times dy dx of f of x. And you can also use the addition, that dy dx of fx plus gx, this is same as dy dx of fx plus dy dx of gx. Use these three rules, 1, 2, and 3, and try to compute this question. Okay, already done. Yeah, it's easy, simply. So what is your dy dx of f of x? So this will become that dy dx of x cube plus 4 times dy dx of x square minus 5 times dy dx of x and plus dy dx of, or we can write as 6 times dy dx of 1. And this again a constant function will become 0. So this will become 3 will come before, and it will become x to the power 3 minus 1, which is 2. Again plus this 2 will come before, so that means 2 x to the power 2 minus 1 will become 1. And again minus 5. Now here x to the power 1 minus 1 will become 0. So that's why just minus 5. And this is a constant function. So derivative of constant function is 0. So this will become 0. So this is our final answer, that 3x square plus 8x minus 5. What I want to calculate f dash at 1. So that means 3 into 1 plus 8 minus 5. What do you guys said? Okay. So this will become 6, right? 6 is correct answer, right? Fine. Okay. Now I will give some another formula, that dy dx of a to the power x. This is equals to a to the power x into log base a of x. Okay. So this is a formula that I'm sorry. This is not log base a. This is ln of a. That ln of x. So this is a formula. You can also derive this formula using the
ln
limit.
of a, right, ma'am?
Yes,
Yeah,
ma'am.
ln of a. Sorry. It's not log base a of x, it is ln of a to the power x into ln of a. So that means if I'll put a is equals to e, what will be the formula? That dy dx of e to the power x. This is nothing but e to the power x into ln of e. But we know that ln of e is equals to 1. So that's why dy dx of e to the power x becomes just only e to the power x. Right? Okay. Fine. So these are the two formulas. And you guys know what is the quotient rule for derivative? I mean, I will just, not quotient rule, product rule first. Product rule. So product rule says that, let's see something, that dy dx of, if you have two functions which are multiple of each other, that is f of x into g of x, then the derivative of these two function is nothing but the first function into with derivative of the second function, g of x, and then plus the second function into the derivative of first function, dy dx of f of x. This is also known as the product rule. So now I'll give you some example to compute. This is the product rule. You guys know this rule, right? Okay, so now calculate the, okay, find your f of x is something 1 by x and x square plus e to the power x. Okay, so this is your f of x. So calculate what is your f dash of x. Just try to use the product rule and the formula which we have spoken above, that derivative of e to the power x is same as e to the power x, and use this rule, product rule, and give me the answer. Okay.
Ma'am, is that f dash 1?
Yeah, f dash of 1. Now we'll calculate what is the f dash of x. So here, this is your one function, suppose f1 of x, and this is your second function, suppose f2 of x. Then we have to find the value of d by dx of f1 of x into f2 of x. Okay. So from the product rule, it will say that it is same as f1 of x into d by dx of f2 of x and plus f2 of x into d by dx of f1 of x. So now we'll separately calculate what is our f1 dy dx of f1 of x and what is our dy dx of f2 of x. So dy dx of f1 of x. So that means I have to find the value of dy dx of what is our f1? f1 is 1 by x, right? But this is same as dy dx of x to the power minus 1. So we can apply the formula of x to the power n, dy dx of x to the power n. So it is same as minus 1 into x to the power minus 1 minus 1. This is your n, so n minus 1, right? So it will become minus of x to the power minus 2, which is same as minus of 1 by x square. So this is the value we'll got of dy dx of f1 of x. Now similarly, we will calculate dy dx of f2 of x. So what is our f2? So it is dy dx of x square plus e to the power x. X square plus e to the power x. So this will become 2x plus e to the power x. Now I'll substitute the value of dy dx of f1 as a f2 of x in our formula. So this will implies that dy dx of fx is same as, first we'll write f1 of x, which is 1 by x, into dy dx of f2 of x, which is 2x plus e to the power x. Then I'll write f2 of x, which is x square plus e to the power x into dy dx of f1 of x, which is minus 1 upon x square. So if we try to solve this, or we can just compute what we want f dash of 1, right? So f dash of 1 is nothing but is equals to 1 upon 1. So this will become 1 and this will become bracket of 2. And we'll put the value of x to be 1. So this is just 2 and plus e to the power 1. And again plus this will become 1 plus e to the power 1. And here we go, minus 1, right? Okay. So at the end, this will become 2 plus e minus 1 minus e. So it got cancelled out. 2 plus 2 minus 1 will be 1. So this is the value of f dash of 1, right? Okay. Calculation error. Okay. Good. So these are the just basic rules for calculating the derivative.
Management. Can you show that?
Sorry,
I want to copy it.
you want to copy? Yeah. But I will share the PDF, so don't worry about that. I mean,
Okay.
yeah. I'll share in the chat box at the end of the class. Okay. So now, from product, we obviously generally ask what do you, how to calculate dy dx of fx by qx, right? If we are calculating product, we also can calculate quotient, right? So there is one way to calculate quotient is that just apply the product rule for f of x into, right? This can be written as dy dx of f of x into 1 by gx, right? So we can apply the product rule for calculating this derivative. So in general, this has some nice formula that dy dx of fx by gx, this can be written as gx square. And here it comes gx and dy dx of fx. And then we have minus sign. And then we have fx into dy dx of gx. This is called as quotient rule. This one. Quotient rule. Okay. So first we observe product rule. Now this is a quotient rule. So these, and one more rule, which you guys know this rule, right? I mean, this basic.
Yes, ma'am.
Then there is one called chain rule. These two rules are so basic for calculating derivative of any function. So chain rule says that if you have to compute dy dx of composite function, that if you want to calculate dy dx of f composite g of x, this is same as dy dx of f of gx into dy dx of g of x. This is known as the chain rule. I mean, first you calculate the dy dx of f, but at a point g of x, and then you calculate the derivative of g at a point x, right? So this simply means that f dash at a point g of x, and this is that g dash of x. This is known as chain rule. I mean, we are working in chain, right? First, we are evaluating the derivative of f at a point g of x, and then we are multiplying it by the derivative of g at a point x, right? So this is known as chain rule. They are also used in several places. For example, if you have to calculate the derivative of e to the power x squared, so what will be your answer? What is f dash of x?
2x 2x e to the power x square.
Yeah, correct. Because this function can be expressed as e to the power x square, right? Okay. So if I'll assume some function f1 of x is e to the power x and f2 of x is x square, then this function can be written as a composition of that f1 composite f2 of x, right? Because if I'll compute f1 composite f2 of x, it will become e to the power x square, right? Yeah,
Yes.
someone saying something? Okay. Yeah, so here you can use the chain rule for computing the derivative of function. So then this will become, then if I want to find f dash of x, so it will become that f1 dash or at a point f2 of x and then into of f2 dash of x, right? Okay. So in general, if I want to find f1 dash, what it would be? My f1 of x is e to the power x. So in general, f1 dash of x is nothing but e to the power x. But I want f1 dash of f2 of x. So this will be equals e to the power f2 of x. And what is f2 of x? It is nothing but e to the power x square, right? So that means this value become e to the power x square, right? And what is f2 dash of x? So f2 of x is simply x square. So f2 dash of x is nothing but 2x. So it will become multiplied by 2x. So this is same as 2x e to the power x square. This is the use of chain rule. I mean, you can just go through using the chain. First calculate the value of f dash of x at some point and then calculate the remaining function at some point. Okay. So these are the most fundamental rules for computing derivative of a function: product rule, chain rule, and quotient rule, right? Okay. Now I'll give some trigonometric functions derivative.
Ma'am, I have a quick question on that one.
Yeah, you can ask.
Suppose if I have sine square of tan x,
What do you have?
sine square
Square of 10x.
tan x.
Yeah.
In this case, this
Mhm.
square would go out first, and then I do cos, or first I do the square one, that is sine times tan x, 2 sine times tan x.
So here you have
Then
of 3 function. Yeah, you can see.
so what I was saying was, will it become like 2 sine times tan x
Yeah.
and cos
Next.
of tan x,
Yeah, and
and
then
then
dy dx of 10
cosecant
x.
square or secant square x.
Yeah, 6 square x. Because this is nothing but if you say f1 of x is x square, f2 of x is sin x, and f3 of x is tan x. Then you observe that your f is nothing but f1 composite, f2 composite, f3 of x, right? Because this is equals to that f1 composite f2 of f3 of x. But what is f3 of x? F3 of x is nothing but 10x, right? So then
Right.
this is nothing but f1 composite f2 of x. Then this will become sine of 10x, right? And then you do f1. So this will become sine square of 10 of x. Now here you will use chain rule. So it will become f1 dash of at this point, that f2 composite f3 of x, right? Then you product with f2 dash of f3 of x, and then you product with f3 dash of x. Now it is clear?
Ma'am, but sine square x, isn't it equal to sine x square?
No. Sine square x is something like sine x into
Sine
sine.
x whole square. Okay, sine x whole
Yeah.
square. Okay.
And the
Okay,
sine
got
of x square is something different, right? Both
Okay,
have
got
different meaning. Yeah.
Hmm.
So we know that d by dx of sine x is equals to cos x, right? These formulas you can also derive using those this limit definition, but it is just calculative, or you can see in any of the book they have given the proof. But now you just remember these limits, that d by dx of cos x is minus sin x, d by dx of 10x is 6 square x. And for other three functions, you can use the quotient rule or product rule to compute the derivative. But I will suggest that you should make a list and remember all the formulas, all the basic formulas. That would be helpful. Okay, so now I'll give an example. I'll give the same function, calculate f dash of x of e to the power sine square of x square. Okay. Just try to find the derivative of this function, use chain rule, and use the formula which are known for trigonometric function, that we know that d by dx of sine x is cos x. Okay, fine. So now we will calculate what is the f dash of x. So here you observe something that, okay, first there is some exponential function, and in the exponential there is some trigonometric function. But for trigonometric function, there is also some power of trigonometric function. And then we have here our usual x square. So you can interpret is as, suppose your f1 of x is e to the power x. So first I'll see exponential. So that's why I'll take f1 of x is e to the power x. Then I see some sign, but then also I've seen that there is some square of sign. So that means we also have to take f2 of x to be x square. Okay, then we have this, we have done with exponential, we have done with a square. Now we'll go for trigonometric function. So f3 of x, I will take sine x, and then again f4 of x, I will take x square, because there's some x square of sine, not just sine of x, there is sine of x square, right? Okay, so here I observe that my function f is okay. So I calculate f dash of x for this fx. Okay, so my function f of x, this something look like f1 composite, f2 composite, f3 composite, f4 of x. You can easily see this is correct or not. Okay, so if I'll apply f4 of x, this will become x square, and then apply f3, so this will become sine of x square, and then if I apply f2, this will become sine square of x square, and then if I apply f1, this will become e to the power sine square of x square. So that means my f is nothing but the composition of these four functions, right? Any doubt on this? No? Okay. Now I have to calculate f dash of x. So I'll just use chain rule. So this will become that f dash of the remaining thing into f2 dash of something and into f3 dash of something. And similarly at the end of f4 dash of x. Okay. So what is our functions are? So f1 is e to the power x. So f1 dash of x will become e to the power x itself. f2 dash of x will become 2x, correct? f3 dash of x will become cos x, and f4 dash of x will become 2x again, right? Okay. So f1 dash of this remaining thing. So that means that e to the power of x, in place of x, what I will have? f2 composite, f3 composite, f4 of x. And then again into f2 dash of something. So what is f2? So f2 is 2 into, so that means 2 into the remaining part, that is f3 composite f4 of x, right? Okay, into now again f3 dash of, so that means cos of again into, which is our f4 of x, and at the end I have f4 dash of x, which is again 2x. So this should be your answer. That's e to the power. What is f2 composite, f3 composite, f4? So if I'll apply f4, this is same as, if I apply f4, this will become x square. If I apply f3, this will become sine of x square. And if I apply f2, this will become sine square of x square. Okay, the same as sine square of x square into 2 times. Now what is f3 composite f4? So this will become x square. And if I apply f3 on x square, this will become sine of x square. So this is sine of x square. Now into cos of, what is f4 of x? So this is x square. So cos of x square into 2x. So this is your answer using chain. Okay. I'll give some short. So any doubt on this question?
We don't have to simplify any further, right? We can just leave it here.
Yeah, you can leave it here. You don't have to multiply, do something else.
Oh.
This is the fine. This is fine. Okay. So intuitively, I mean, this process will little bit lengthy, that you, I mean, it depends on your practice how fast you can do. But I will tell one thing, that if you want to calculate the derivative of sine e to the power sine of sine square of x square, what you will do? So assume this is something t. Okay. And then just calculate what is the derivative of e to the power t. So it is e to the power sine square of x square, right? Now move inside. So this is sine of x square. So if you assume sine to be something, suppose this is your t1, suppose you assume this is some t2, that you will assume this is same as sine of x square, the whole square, right? So you'll assume that this is something t2. So now just try to find the derivative of this function. So it will again become 2 times sine of x square, right? Okay. Then again into, then you do the derivative of sine. So it will become cos of x square. And then again you do the derivative of x square. It will become 2x. So this is one. This is also some short trick to find the derivative of some composite function. But it will require some practice. Okay. As you practice, as you do more questions, it will become more handy. Okay. It's easy stuff. Now I'll just recall the other derivative formulas, some inverse trigonometric derivative formulas. So we have done till 10, right? Okay. So now what is the derivative of dy dx of cosec x? This is same as minus of cosec x into cot x d by dx of sec x. This is same as sec x into tan x, and d by dx of cot x. This is equals to minus of cosec square of x. Okay, so these are the some remaining trigonometric functions derivative. Now, what about inverse trigonometric functions derivative? I mean, what do you mean by d by dx of sine inverse of x? So this is nothing but 1 by under the root of 1 minus x square, and d by dx of cos inverse of x is just nothing but the negation of this thing. Okay, so it is equal to minus of 1 by under the root of 1 minus x square, and the derivative of tan inverse of x, this is equals to 1 by 1 plus x square. These all formulas can be derived using the same trick, or either the limit or just some computation of functions. I mean, you can see NCERT books. I think they will contain the proof of these functions. Okay. So these are the inverse trigonometric function, and we also have something about log, that d by dx of ln of x, this is equals to 1 by x, and d by dx of log base a of x, this is equals to 1 by x of ln of a. Okay, So obviously we are defining log, so that's why our x should strictly greater than 0. And our a should not equals to 0 or 1, whatever condition apply for log. Okay, so these are the basic formulas for using for doing the derivatives. I think this much you need. Okay, so I'll again revise whatever we have done. So for first thing, we have list out the limit, that we say that the limit exists if the right hand limit and the left hand limit are same. Okay, then we did continuity. So for continuity, our limit, that limit extending to a f of x, this should equals to f of a. Then we define what do you mean by differentiability at a. So this is nothing but f dash at a is limit h goes to 0, f of x plus h minus f of x by h. I'm sorry, this is f of a by h. And here we have also defined what do you mean by right hand derivative and what do you mean by left hand derivative and right hand derivative. So left hand derivative is nothing but this limit, that limit h goes to 0 minus of this function f of a plus h minus f of a by h. And the right hand derivative means the limit of this limit, that right hand limit of this function, f of a plus h minus f of a by h. And then we say that this limit is same as limit z goes to x, f of z minus f of x by z minus x. Someone saying something? Does anyone know the recording of it? So these are the three things we have done. Then we stated some basic rules for doing the derivatives. First rule is simply addition, that we can distribute the addition and scalar multiplication. Second rule is the product rule. And then we did the quotient rule. And then we did the chain rule. So these are the 7 things we have listed out so far, and some basic formulas. Okay. Now, at the end of session, I am going to discuss what do you mean by L'Hospital rule. Okay. It's better to write myself. Okay, so if we want to find the limit of something, that limit extending to some a, f of x by g of x, right? Here your fx and gx are any functions, need not to be polynomials, any functions, right? Okay. Okay. So then, if you want to find the limit of this quotient f of x upon g of x, and if we get that f of a by g of a, this is either 0 by 0 or infinity by infinity. One of those things will help us. Okay, so then if we want to fine, so then this limit, that limit x goes to a, f of x by g of x, this limit will be same as this limit, that limit x goes to a. In place of f, you just replace f dash of x. In place of g, you just replace g dash of x. This is known as L'Hospital rule. But take precaution that you just have to use that 0 by 0 form or infinity by infinity form. No other form will work. Okay. I think you have questions on assignment based on the L'Hospital rules. So now any doubt from the assignment questions or practice assignment question?
Yes, ma'am. Ma'am,
Yeah.
can we solve one of those questions wherein we determine the tangent or solve the equation where variables are a, b, and these are sort of questions are given?
Which one? I don't remember. I mean, the equation of tangent or what?
Yeah, let me look up. Just give.
Yeah.
Ma'am, I have a doubt on a practice assignment.
Yeah.
In question number 3, where graph is given.
Could you
In
please?
that,
Okay, wait. Yes. Which practice assignment question? Na week 8.
yes, ma'am. Question number 3.
Question number
3.
3. Yeah. The value of function at the point and the value is limited by the rule of function. Yeah. You have given some function using the graph and then they are asking some limit, right?
Yes, ma'am.
So
For
it is
that,
equal to-
we don't consider the hollow points, right? In
Yeah.
x where y is equal to 10. But in the options, option 1 is correct.
Option 1 says that limit x t tending to 2 minus. So that means here it is asking the right hand limit of fx at a point 2, right?
Yes, ma'am.
Yeah. So
I thought that at point 2 from right, left hand side. Sorry, it is
sorry. Yeah. 2
left hand.
minus is left hand side. Yeah, correct.
Yeah, so it is not considered point 10, right?
Yeah.
The option. So option is incorrect. Option was, but in the solution it's
So there is
correct option.
Okay, let me check. So accepted answer are, yeah, first option they are saying that it is correct. But it is
How it is
actually
possible?
not
Ma'am?
correct.
Because follow we didn't consider it in a function.
No.
How it is correct?
Okay. Yeah, got it. What is your point? Right. Okay. But actually this option is true. Why I will say. So what is happening there? That in that question we have given some graph, something like this, and something like this. And this at 2 point the function is not defining the value 10. But what happened when we calculate the limit, that limit x goes to 2 minus f of x, right? So we try to go as near as possible the point 2, right? So if you travel using this graph, you will get more closer and closer to 10, but you never reach to 10. But that's not important. What do you mean by limit? I mean, at some stage, I mean, suppose I'll say that you go closer and closer to 10 such that your distance will become so small, right? You can do that, right?
Okay.
Yeah.
Yes.
So in that case, we can say that so limit is also equal to 10. So that means this is true. I mean, in the limit, you never bother that the function is defined at that point or not. We just have to say that in a smaller neighborhood of that point, what is happened. So if I'll consider some small neighborhood of 10, you can easily go to that small neighborhood, right?
Yeah.
Yeah.
Then, ma'am,
So,
then option 3 will also be correct in that matter.
we'll take what is option 3? Option 3 is 6 minus. Yeah, but here observe that. I mean, if you go from the left hand side of the 6, you will reach to 10 in the neighborhood of 10, not in the neighborhood of 5. Yeah, so the option 3 is also correct, right? It is given to.
But it's it
is
is
acceptable,
yeah.
yeah.
Okay.
Okay, yeah. Fine.
Ma'am, last 3 questions in the practice assignment.
Last 3 question of what?
Practice assignment.
Practice assignment, last 3 questions, okay. I mean 9, 10th and 11th.
Yeah, 8, 9, 10. 8,
9, 10th. So let LF do what is the linear approximation function. So there is some formula for the best approximation function, right? I mean, I don't
Yes, ma'am.
remember now. There is some formula for LF.
Yes, ma'am.
What is it?
F dash of a x minus a plus f of a.
Yeah, f dash of a plus x minus. No.
No,
What
ma'am. F dash of a into x minus a
f dash of a into x minus a, right?
plus
And
f of a.
plus f of a. Yeah. So this is just the equation for tangent. Fine. So what does the question says to us? That the ft be not the best approximation of f of t at a point t is equals to 1. Assume that f to be continuous at t, then find LF of 1. Okay, so we have to find LF of 1, right? So what is LF of 1? So LF of 1 is nothing but f dash of,
1.
this will A or X,
A.
A, ma'am.
and this is LF of X. Check. So it is f dash of A into 1 minus A will be there and plus f of A, right?
Yes, ma'am. Linear approximation f of x equals to f of a plus f dash of a times x minus a. That's the formula that I have.
So here can we use the limiting definition? I mean limit x goes to 0 f of A plus h minus f of A by h into 1 minus A plus f of A. So it is given to us that f is continuous at
Right.
which point?
1.
T equals to 3.
At t is equals to 3, it is
Equals to 3,
continuous. So that means limit t goes to 3, f of t, this limit will exist. What is the condition for I mean best approximation at what point they're saying? Point t is equals to 1. Okay, I will check this question. Actually, I haven't solved it. So
Okay.
the answer is 1, I think, now. I mean, I think it's 1. Okay, fine. I will let you know in the next section. I haven't gone through the linear approximation stuff till now. But I think you should use this somehow use this limit, okay? So if you have limit t tends to 3, f of t, this should equals to f of 3, right? So if you replace t by 3 minus h, then what you will get? That limit h goes to 0, because if t is equals to 3 minus h, then if h goes to 0, then here t is also going to 0, right? Right?
T is going to 3.
Yes, ma'am.
Yeah, sorry. I mean, this limit will be same. So this is f of 3 minus h is equals to f of 3. Okay. So that means that limit h goes to 0 of f of 3 minus h minus f of 3. This limit becomes 0. So you somehow try to use this limit. I think there is some correction between this limit and the question. Okay. Or otherwise, I will discuss in the next section once I do.
Okay.
Thanks. Any other doubt on the derivative or L'Hospital or any other doubt we can discuss? The limit continuity part. Any question from the practice assignment or activity questions we can discuss, because this is the only stuff I have to do.
Yes, ma'am. Activity 8.1, question number 5 and 4.
What is the doubt in the fourth question?
Yes, ma'am. Why not f is always continuous? I'm unable to visualize it.
Okay. So just take some particular value of t. Suppose a is your 2 and b is your 1. Okay. So then what will be our fx? So fx is equals to 2x and this is x square, right? When x is less than or equal to 1, or this is the function, right?
Yes, ma'am. Just change the if condition. For
Change
2x, x is greater than or equal to 1, and for x square is x is less than.
Okay, yeah. Change the inequalities, yeah.
x greater than equal to 1.
And this is greater than equal to, this is less than, right?
Yes, ma'am.
Yeah.
So just try to draw the graph. Suppose this is my x is equals to 1 line. Okay. So what is the value of x at x is equals to 1? At x is equals to 1, the graph is taking value 2 into 1, which is 2, right?
Yeah.
So suppose this is your y-axis. This is 2. Okay. So this is the value taken by the graph. And when our x will be greater than 1, then our function look like some 2x. So that means this is, right? This is 2x,
Yeah.
right? But if you observe that if our x is slightly less than 1, then it will take, suppose my x is something 0.999999 and so on, right? So
Yeah.
then this function will applicable, right?
Yes.
And at this point, the function will be nearer to 1. I mean, something like this,
Okay.
right? So
Yeah,
there
yeah,
is
got
a
it.
1 unit gap between the function. So that's why it won't be continuous always.
Yeah.
For matching these 2 points, we need some conditions on A and B. So now it is clear, right?
Yeah, yeah, it's clear.
Okay. And which question? Fifth.
Option 4.
There exists an unbounded continuous function from 2, 3 to r. Okay, you are not able to find the unbounded function, right?
Yeah.
So whenever the question asks that unbounded function on some interval, suppose one is open or another one is open, doesn't matter. Suppose open A and close B, okay? Then use this function that f of x is equals to 1 upon x minus, right? Then you observe that as x goes nearer to A, the function will tend to infinity, right? So if this is my x is equals to A line, this is my function, right?
Yeah.
Yeah, so this is the unbounded function in the interval. Okay. Fine. So in case
And
of you, this is 2 and 3. So just take f of x is equals to
1 by
1
x
by
minus
x
2.
minus.
Yeah.
This is
Okay.
general unbounded.
Yeah.
Any
And
other doubt?
for option first and second, we just take the argument because both the
There is a
uh,
continuous function.
domain and
Yeah,
codomain
yeah.
are the bounded,
For
and
option
such
what?
that the function is given for option 1 and 2
Okay, for
to
option
4 or
1, you
5.
can easily take constant function itself. Just define f of x is equals to pi, that will work. No, but that won't be continuous. No, yeah, that will be continuous. Doesn't matter. Fine. So you got the function, right? There are so many functions. I mean, you can think easily. Fine.
Yes.
Ma'am, in previous question, this before this,
This one.
yeah, if it is given this function is continuous, okay, and the instead of x square, it is given ax square, and find the value of a. Then what is the procedure to find the a if it is given this continuous?
Okay, I mean, what you are asking that this is some bx and this is some ax square. Then what is the procedure for finding a and b, or simply a?
Yeah,
I mean, the
if
b is
it is
also
continuous. No, b only 2x.
okay. So just try to use the definition of continuity. That means you have limit extending to 1, f of x. This should be equals to f of 1, right? But in
Okay.
the limit, you also have 2 limits: the left hand limit and the right hand limit, right? In
Mhm.
this question, if we observe that what is the left hand limit, so that means I have to come to a from the left hand side. So that means I have to apply this function, right?
Okay.
So so this function, so that means limit extending to 1 minus of x square. So this will become simply 1, right?
Mhm.
Because if you observe this function, as we come from the left side of 1, we will go near and near to 1. In the limit, it is not always the case that you should get something on the point. It's okay if you won't get anything on the point. You just have to go near and near to that point. I mean, you're getting my point, right? You should be able to find more closer and closer to that point. Okay, so here left hand limit will
Okay.
become, I'm sorry, if your case is A, so then this will become A.
Okay.
Got it?
Okay, and what will be the value of A then? If we have to equate it with 2x,
Yeah.
in which
Then
x
this
is equal
is,
to 1. So A
yeah,
will be 2.
yeah, then A will be 2. This is the
Okay,
process.
okay.
I mean, you have 3 things. You have left hand limit, you have right hand limit, and you have value of function. So if you want continuity, those 3 things should be equal, right?
Yeah.
So from these 3, you can get the value of E.
Okay. Okay, thank you.
Any other doubt from activity question or anything? I will get back to you for that approximation question. Now I'll try to solve it, and then I'll say what the answer. LF. No. So don't have any doubts.
No, not clear.
Okay. So I'll share the PDF, then you guys can leave. Okay. So people are leaving now. Okay, fine. So does anyone share facing any problem, technical issues, or what? Anything else?
No, no.
Okay. And then you guys can leave. Okay. Good night, everyone.
Yeah, good night. Please share the
Yeah, I have shared the
annotations.
PDF. Yeah. PPT is shared.
Thanks, ma'am. Ma'am, video is working.
Sorry, what?
I'm saying, ma'am, PDF is working. Thanks, ma'am. Bye.
Okay, yeah. Thank you. Bye. Good night.
You too, ma'am.